Welcome back. So today we're going to be talking about some special triangles. So the first page that we're looking at is page 281 in your notebook, and this is our 45, 45, 90 triangle. So with a 45, 45, 90 triangle, we have two angles that measure 45 degrees, and then we have one that's 90 degrees. So then our sides, which we call the legs, are congruent. And the hypotenuse is the square root of 2 times the length of the leg. So for our ratios for our sides, we have an n, and an n square root of 2. Okay? And the reason why we use n instead of x is because we oftentimes use the variable x and y for other pieces of missing information, whereas this is kind of a template for what the sides are and the relationship between those sides for this special kind of triangle. All right, so then what it looks like on an actual 45, 45, 90 triangle up here. So we have this side is a leg, so that's going to be n. This side is also a leg because these are the two that are adjacent to our right angle. So again, it's going to be n. And then this one is our hypotenuse because it's opposite of our right angle, so that's n square root of 2. So then just a couple things to think about here. So if we're trying to find the hypotenuse and we know the leg, we're going to take the leg times the square root of 2. And that's going to give us our hypotenuse. If we're trying to find one of the legs, we're going to take the hypotenuse divided by the square root of 2, and that's going to give us the n, which is one of our legs. So we have a couple examples down here. So we're going to go through these together. So we're going to find the value of x for each of the triangles. So for the first one, what I like to do from the very beginning is I'm going to identify which sides are n and which ones are n square root of 2. So if I look at this first triangle, my sides, my legs are n, so my 8 is n. My hypotenuse is n square root of 2, so n square root of 2. So by writing these equations out, now I already have equations to be able to solve. So I'm solving for x, so I want x equals n square root of 2. I know that n equals 8, so I can substitute that in. And I've already found my x. Okay, let's move on to the next one. So I'm going to do the same thing. I'm going to decide which of my sides are n, which ones are n square root of 2. So 6 square root of 6, that's one of my legs, so that's n. And the x is my hypotenuse, so that's n square root of 2. So then again, I have my equation here. So I'm going to write x equals n square root of 2. Over here, we found that n is 6 square root of 6, so I'm going to substitute that in. So 6 square root of 6 equals my n, and then we had a square root of 2 there. Okay, so then for this one, we're going to multiply our like terms. So I'm going to multiply my square root of 6 and my square root of 2. So I've got 6 times the square root of 12. Okay, because my square root of 6, square root of 6, or excuse me, square root of 6 and square root of 2, 6 times 2, it gives me 12. So now from here, I have to simplify this radical. It's not in its simplest form. So I'm going to look at the number 12, and I'm going to find all of my factor pairs. So we have 1 and 12, 2 and 6, 3 and 4. I want to find a factor pair with a perfect square in it. So if you remember back to your perfect squares, 2 times 2 is 4, 3 times 3 is 9. So numbers like 4, 9, 16, 25, 36, those are all perfect squares. So this factor pair of 3 times 4 has a perfect square of 4. So I'm going to break this 12 down. So now it's going to be square root of 3 times square root of 4. I know the square root of 4. It is a perfect square, and that's 2. So now, outside of my radical signs, I have a 6 and a 2. So I'm going to take 6 times 2 And then I still have my square root of 3. So I get 12 square root of 3 equals my x. And that is simplified. Okay? I know I wrote out a lot of steps here, but I just want to make sure that you understand where all these different pieces are coming from, because you will be expected to simplify your radicals. All right, so going on to the next one. Again, I'm going to identify which ones are in and which ones are in square root of 2 first. So my leg is in, my hypotenuse is in square root of 2. So then from here, I want to solve for n. So if you look at this one, without even having to do any algebra, if 8 square root of 2 equals n square root of 2, then I know that my n has to equal 8. So then x equals 8. We could also go through and divide by square root of 2 on both sides and be able to solve and get 8 that way as well. Okay? All right, so then the last one that we have here, my x equals n, because that is one of my legs. The 10 equals n square root of 2. Okay, so then from here, I'm going to take my equation 10 equals n square root of 2, and I need to solve for n, so I'm going to divide by square root of 2 on both sides. That means they cancel out on the right-hand side, and I'm left with n. On the left, I have 10 over square root of 2. Now, I don't want to leave this square root of 2 in the bottom. We don't like to leave radicals in the bottom. So I'm actually going to multiply by square root of 2 over square root of 2 so that I can get rid of that off the bottom. Okay? Now, whatever we had here on the bottom, that's what these two numbers would be. If this was a square root of 3, we would multiply by square root of 3 over square root of 3. If this was a square root of 8, I'd multiply by square root of 8 over square root of 8. Because whenever we multiply by this number over itself, that's 1. And so we use our identity property to say we haven't changed anything over here, because anytime you multiply by 1, it stays the same. The other reason why we do that is because if I take the square root of 2 times the square root of 2, so I'll show you over here, two different ways you can think about this. One is we can say that this is the square root of 2 squared, or we can say, just like what we did up here, we can say this is square root of 4, which equals 2. If we look at it like this, square root of 2 squared, square root and squared are opposites of each other, so those cancel each other out, and you're just left with the 2. Either way, this bottom piece becomes 2. So now we have 10 square root of 2 over 2 equals n. So now I have to simplify this 10 over 2, and that becomes 5 over 1. So now I have 5 square root of 2 equals n. Okay, and we know that n equals our x. So we can say that equals 5 square root of 2 there. Okay, all right. Great job with that. So that is all that I have for the 45, 45, 90 triangles. Make sure that you watch the next video because we'll also be talking about 30, 60, 90 triangles.